Well, hey there everybody, welcome back. Today we're working on part 3 of a neon processing plant setup. Part 1 was the build of the bench, part 2 was the wiring and electrical, and part 3 today will be the vacuum system. Those first 2 videos, if you want to see those, check them out. Link in the description below or card in the corner if that's working. We'll do a quick overview of the parts we got, all the equipment, and then we'll get it set up. I got this equipment I bought up, used neon shop equipment about 3 years ago, and I'm just now finally got it all situated, organized, and everything I need to get it set up. So we'll start with the pump. This is a vacuum pump, which is kind of the heart of the system, and that connects to the manifold. I got a borosilicate manifold here. And we have the noble gas, the rare gas tanks. I have this gas transfer system here. As mentioned, this was previously used as a, I think, a production shop, and in the parts they had some of this archaic leftovers. I believe this is what they must have had set up before they bought this borosilicate. But this is kind of a hybrid mixture of what appears to be a metal manifold and ground glass stopcocks. These ground glass stopcocks were the kind of the old technology, the way they used to do it from basically I believe the inception of neon up until the invention of the greaseless stopcock borosilicate manifold in 1989, I believe it was. So first 75 years or so were these, and I've heard them described as quite a pain in the ass because you have to take these apart and clean them and lubricate them all the time. You can see the grease kind of clogs up and collects dust and dirt, and but they do work, and they're just not used very frequently anymore. Some shops still have them set up, but it's kind of the old school way to do it. Here's what appears to be a U gauge, handmade, I guess. This is just a section of hose with some marks on it for gas fill pressure. I can't imagine that worked very well, or if it was very accurate. And it seems they had some leakage problems. There's silicone globbed all over it. So I'm not sure if this is a particularly brand of manifold, but only one I can think of is Townsend. I'm not sure. Never seen one before, I guess. So it looks like a ground wire for flashback on that thing. But as mentioned, this it was kind of an old school setup. The newest part about it was this borosilicate. They didn't have any gauges. They used newspaper instead of a temperature gauge. They didn't have a milliammeter gauge, and they didn't have a vacuum gauge. So all those 3 gauges I had to purchase separately, along with this vacuum gauge. Stopcock is brand new. Will attach to the manifold as well. So I am just learning to do this, so I need all the help I can get with these gauges. So also do not have a diffusion pump, which may prove to be problematic later, but we'll see how it works with just this mechanical roughing pump. Did not come with a stand for the manifold, so I had to fabricate one. I looked at pictures of the old Deco setups, and I got this built, and I made this bracket for the Robbins valves on the gas transfer system. So I've already rebuilt these Robbins valves, and I just put them on the way they were set up when I got it. But anyway, what we got to do here, first we'll have to start off, flush and fill the vacuum pump. Then we'll have to clean and assemble the borosilicate manifold, clean and fill the U gauge, attach the gas transfer system, and finally, when it's all assembled, we'll connect it together, attach the manifold to the vacuum pump. So, without further ado, we'll get started. Okay, so this is the vacuum pump. This happens to be a Cenco HyVac 7. It has a Daco badge on it, nameplate with the matching serial number, so would imagine that this was probably rebuilt by Daco at one point. Most of my equipment here is Daco brand, and they were a neon shop supply company based out of Papillion, Nebraska. Went out of business in 2008, so that kind of gives you an idea of the age of some of this equipment, old, 12 plus years old. This vacuum pump is definitely very old. When I was ordering the pump oil from HyVac, who, yes, still manufactures this model, they said, the lady was like, oh, your vacuum pump's probably 40, 50 years old. And they have plenty of them that are still in service, apparently. So this HyVac 7 model is, let's see, it is a about 79 cubic liters, or 79 liters per minute of free air displacement, which is on the lower end of what we want for a neon plant, but it may be adequate. If it's not, after this flushing, I might have to get a rebuild kit, but we'll do that one step at a time. This is a dual stage, a 2-stage belt drive rotary vane pump. They're super simple. They're basically bulletproof, tried and true. This is why they still sell this particular model 50 years later and it hasn't changed at all. But there's basically not many moving parts. You got the main shaft and the rotors, the 2 rotors that are on the shaft, and those are about the only moving parts, except for, of course, maybe like a couple one-way valves. So really simple, not a lot to fail and go wrong on these. But what I wanted to do, I wanted to retrofit this with, instead of this hose barb we have on here, I wanted to retrofit it with a KF25 adapter. KF is an ISO standard genderless vacuum fittings. KF is German, stands for Klein Flanche, which means little flange, and the number on the KF flange is the maximum nominal inner diameter. So, okay, this is a KF25, so maximum inner diameter of 25 millimeters there. So, but I'll be attaching it into the intake here. This is a 1/2 inch NPT, and I'll save that little debris trap catcher thing, and I'm going to use stainless Teflon tape, PTFE tape, designed specifically for stainless, since stainless threads are prone to galling and seizing, so we'll hopefully avoid some of that with that special tape. So I got the threads taped up here, and we'll screw this flange into the intake. All right, I think that's pretty good. And expanded out the little screen here. Slide that guy in there. Push that down in there a little bit. All right, that'll do. All right, I've never run this pump before, and this motor requires oiling annually. So what I want to do is oil the bearings on that guy first before we try to run this. This pump does, I've turned it over by hand, and it does generate a vacuum. So it works in that respect. But what we'll do here is we'll get this old belt off, we'll deflect it a little bit, and then just rotate, get rid of that. And I'm going to oil these bearings with some turbine oil. These little plugs. There we go. I use this oil to oil my Vornado fans, my vintage Vornados. Let's see. Fill that channel up. I don't know when the last time this thing was lubricated. So, I mean, obviously, I've owned this 3 years. I haven't run it, but it was over 3 years ago. Last time it got oiled, so. Might be a tad dry. So I'm going to turn that pump on and see if it'll suck up some of that oil for us. Very good. Motor does work. I have tested it without the pump, belt on. So that looks good. And I'm going to replace the belt with a cogged belt. I was looking for a replacement, and everything I read about belts, I said cogged belts were more flexible and they lasted longer and they ran quieter. So why wouldn't I want a cogged belt? So we'll do that. We'll take that guy on there. And I guess there's no oil in the sight glass, so what we need to do is fill that up. All right, so we'll fill up the oil in through the exhaust port, and you guys keep an eye on the level there. Tell me when it's in the sight glass. We're low on oil because this system wasn't shut down properly, and it sucked a bunch of pump oil into the manifold. Someone had just turned the pump off, and then there was the residual vacuum in the manifold, sucked it all up. So that's the oil level. All right, that looks good for the initial warm up. We're gonna start it up and then we'll warm it up so we can drain it and then flush it. Okay, now we got oil in the sight glass. I think we're ready to fire this up. So, moment of truth in 3, 2, 1. All right, it's going. The belt seems a little loose. I might have to slide that motor over just a tad. But we can worry about that when mounting it later. So, I've never seen one of these in operation, so couldn't really tell you if that's normal or not, but we'll let it run, warm it up, and then we'll drain out that old oil and flush it. All right, now we got to clean the manifold. Parts we have here are the main stopcock, manifold body, the debris trap, the pumping attachment, and then the U-gauge. There's one issue we need to address before I'm going to run it through the ultrasonic cleaner, but before I do that, one issue we need to address is it seems the previous owners of this setup did mercury repairs. I don't know if you can see these little beads of mercury all up in here. Like right there. So they're just kind of all contaminated the system here. So I have to reclaim those, trap them, and collect them before I run it through the cleaner. But get those out of there and then clean this thing up. So I'm in the process of cleaning the manifold bits, and I wanted to show you this is the U-gauge, Normally it's filled with butyl phthalate, but I wanted to show you what butyl phthalate does to Viton O-rings. This kind of turns them into mush. If it comes in contact with Viton, it dissolves them. So I will be upgrading the fluid to Dow Corning 704, which is commonly used in diffusion pumps because it is safe to use with Viton. So we'll pour that out and then run this guy through the ultrasonic cleaner, and then we'll be filling it back up later with Dow Corning 704. All right, now that we're away from the ultrasonic cleaner, I can actually tell you what was going on there. I got everything all shiny and clean. Look how pretty that looks. Ooh, I'm glad those Daco decals stayed on there. I wasn't sure if they would get taken off by the ultrasonic cleaner, but they're still intact. So that's kind of a fun part of neon history. So I wanted to keep those if possible. But anyway, they got it all cleaned out. I used, well, I have the original manufacturer's cleaning instructions here. And they mentioned powdered glass cleaner, so I kind of took a guess that was Alkanox. I used that, and it worked out really well. And then I did a final rinse with some laboratory grade acetone. And as you can tell, that did a really good job of cleaning, rinsing that out. And I was able to capture that mercury out of there. So got a little bead of that for hazmat disposal. And yeah, I also got the caps and the stopcocks stem, these Teflon stems. I got them cleaned up as well through the cleaner. Clean off that backboard for the U-gauge. So we'll start assembling on the stand there, and we'll get to work. All right, and to make the system vacuum tight, we need seals. These are Viton O-rings, and we got some Delrin Chem Thread caps. These four number 18s, two of them go on the either end of the manifold body. One goes on the debris trap, and the other goes on one end of the bottom end of the main stopcock. Those take a 208 O-ring. This is a number 15 Chem Thread cap that goes on the U-gauge manometer. It takes a 206 O-ring. These three number 9s go on the main the manifold body for our gas transfer or gas bottle stopcock, and the vacuum gauge. If you do, side note, if you do have gas bottle stopcocks, you have a couple more of these, number 15s. And these are number 7. They go on either end of the pumping attachment arms. They take in a 107 ring. Our 12mm stopcock, that's our main stopcock that goes in the top there, that opens our system to the vacuum below. That has 2 sizes, one tip ring O-ring for a 110, and the 2 shaft O-rings are 112. And then we have our 2 4mm stopcocks. One is on the top of our manometer, and the other is in our blowhose slash vent valve in the manifold body. For those, we got a tip O-ring of a 007 and then a 010 for the two on the shaft. So I don't think I mentioned it, but this is a Dayco Precision SE setup. It was their kind of entry level basic. SE means single-ended, so you could pump out of either end. You could attach the pumping attachment to one end or the other, and then the main stopcock was on the other side. So they did have double-ended ones where you could pump out of both ends, and that had a bigger stopcock like in the middle of the manifold, and then you could use both ends of the manifold to pump. But I don't need that. My vacuum pump probably can't even handle two. Oh, and I forgot to mention the debris trap filter that goes on the end of the pumping attachment. Got number 014 to hold that filter on there, so that's another one. All right, assembling the stopcocks here. None of the O-rings on this system should be greased, none of the compression O-rings, so like the stopcock tips and the chem thread compression seals, they should not be greased, but the shaft O-rings on the stopcocks can be greased. So what I'm using is APA's M, suggested by the manufacturer. This is a hydrocarbon grease, silicone free. Using silicone grease on these borosilicate manifolds is not recommended, because if they ever need repair, then the silicone can get sintered into the glass. It gets so hot it can integrate itself into the chemistry of the glass and weaken the glass, cause leaks. So no silicone grease for me. Also, this APA's is a getter, so it'll absorb contaminants. So that's pretty cool. So these caps are left and right hand threaded. The stem inside that goes into the Teflon PTFE stem here is left hand threaded, so lefty tighty on this one. And the inside threads, or the threads inside the cap, are right hand threaded. So, as is the glass here, when you insert it and tighten down right hand threads, the inner shaft gets loosened and it pushes the stopcock down towards the seat in there. So there we are, seated, greased, and seated. Very nice. I got the pump positioned about where I want it under the table there. I got that drain petcock hanging off the edge, so oil changes will be easier. And then I'm going to need to drill a hole in the tabletop for the main stopcock. And I got the new scale temporarily taped on the backboard there. And we're going to fill the manometer with the Dow Corning 704. now for the debris trap. Alright, now we got the pumping attachment with the debris filter on it. This is an aquarium filter mesh bag, not felt. Felt is the wrong stuff. This one is 100 micron. So, and I've been grabbing Kim wipes and get a little acetone, cleaning off the glass where it will be, the compression fittings will attach to make sure they're just nice and clean. All right, now I'm putting the vacuum gauge tube into the vacuum gauge stopcock. Put this vacuum gauge stopcock into the manifold. Next are the Robbins valves for the gas transfer system. On the ends here we have swage lock ultra torque connectors. Those are 3/8 inch, but they fit a 9mm tube pretty well. So torquing them down to recommended spec for the lock nut on the Robbins valve. Put the knobs back on. This red one, of course, will be neon. Tighten this set screw. And this one will be for argon. Can you tell I cut these tubes earlier? Measured and cut. These are ultra torque fittings are just compression, kind of like these guys. So. All right, so now I got the gas transfer system all set up here. Got the tanks mounted to the table, and I upgraded to stainless for as much as I could here. I got the copper lines run into the Robbins valves using these swage lock connectors. And the way this system works is the Robbins valves will be closed, and then you open the main tank, it fills the line, and you close the tank again. So then you just have this metered dose, I guess you could call it, of noble gas, and then you just ladle out a little bit at a time with the Robbins valve into the evacuated tubes. It goes into the manifold and fills the tubes. So that way you have a set amount, and you're not exposing the whole tank to, if you say accidentally open the main stopcock to the vacuum pump and it starts sucking the whole contents of the tank out, that could get expensive. So, but yeah, this way you can have a little metered amount of gas that you can just kind of put little bits into the tubes. All right, so now we're under the table here, working on the pump. I have already flushed and filled the pump. I spared you the tedium of that. It was about an hour-long process, so that's done. Getting the tension adjusted off for the belt, and now we got this 18 millimeter tube coming down from the main stopcock above the table, connecting into the pump here. What I've got is a KF25T with a KF16 on this side, and this little knob is a vacuum relief valve. Since I don't have a diffusion pump with an isolation stopcock that I can vent to the atmosphere, the only other option if you don't have one is just to vent the manifold to the atmosphere, and I don't want to do that. So I decided to go with this vent valve so I can keep the manifold under vacuum and then turn the pump off so the manifold can remain under vacuum. But to connect these two together, I've got a KF25 hose barb here onto this thick-walled gum rubber vacuum hose, and it needs to connect to my 18 millimeter line to the stopcock there. So what this is, you can tell, a little bit long, so I need to cut off a bit of that. So I thought you might like to see that. All right, so maybe where are we in here? What about there? You see that little mark I made? That's where I'm going to cut the... All right, and this here is an electric glass cutter, a Kitco cutter. It's got a little transformer in there and these little contacts that you can connect to. This is the main, and then individual contacts for how hot you want the wire to get, but has this little handle with a wire loop that you wrap around the tube, and it's a nichrome wire, nickel chromium alloy. That's what they use in like resistance heaters and stuff. So, but for example, I got this one's a 9 millimeter, this one's a 15, and I just made this 18 millimeter wire loop for our 18 millimeter tube. So I will set you down. We will cut this tube with the electric glass cutter. All right, so we got the mark here and the Kitco glass cutter. Nichrome wire gets really hot, so all we gotta do is place it on the tube where we want to cut and let it heat up for a minute, actually just a few seconds. So nice and warm, then we sink it with some saliva. Bam, nice clean cut on this large diameter tube, so that's handy. Now we can fire polish it. All right, I'll try to talk over the regenerative air blower behind me. That's what supplies air for the torches here. This is one of the torches commonly used in neon. This is a crossfire. This is called a 5-point or a 5-finger crossfire, because there are 5 torches on each side aiming toward the center. But what happens when you cut glass, the edges are sharp, and that will cut that gum rubber hose if we try to slide that in there. So what we need to do is polish out the edges, and to do that we run it into the flames there, just enough to round out just to melt the edges, to round them out so they don't cut the hose. Alright, and that should be enough. You can see that sharp edge is gone. Now we got a nice smooth rounded glass edge. Fire polishing. Now this is really hot, as you might imagine, because it was hot enough to melt the glass, so we had to let it cool down before we stick it into the hose. Alright, so we got this tube all ready to go. We've got the number 18 connector and a Viton O-ring on our 18mm glass tubing and a KF25 fitting, all connected together with this thick wall gum rubber vacuum hose. So all that's left is to connect them together. Get an O-ring in here. And this is a KF connector clamp. Has chamfered inside edges that pinch the two flanges together on the O-ring to make a seal. All right, and I'll secure the bump to the table, and we should be good to go. All right, got it all hooked up. Motor's back on. Vent valve. Everything's connected. Sealed. I think we're good to go. I hooked up this digital vacuum gauge. This is the HyVac WR100. The WR stands for wide range. It displays a value from atmosphere, which is 760 torr, all the way down to 0 micron. It's most accurate below 2000 micron. So from 2 to 760 torr, it's kind of an estimate, shall we say, but it will display a value. So I got that hooked up so we can kind of see what is going on inside the manifold system. I guess we'll open up the stopcock, yeah? So we can actually have it connected to the system. Supposedly the fluid in the manometer will start to bubble as it outgasses. Everything else will outgas to the rings and the grease and all that. So I'm not sure exactly how this is going to go because I've never done it before. This is the culmination of several years of work and study, and I'm pretty excited about this. All we got to do is start it up. Close this vent valve. The pump is now closed to the system, so we'll turn that on. Alright, I hope you can hear me over the sound of the pump. It's not too terribly loud. It's quieter than I thought it would be. I wasn't sure if the deck of the table would make it resonate, but it seems to be decently quiet. So, we're sucking a vacuum all the way to here now. This main stopcock is closed. Oh, close that vent valve. And I guess this is it. This is the first time I've ever done this. So, let's see what happens. There it goes. It's slurping. That vacuum gauge is going down. I don't know this is accurate. This is used, so maybe. So that's 0. It's going. Maybe this fluid is not outgassing. I don't know. I know I've got it overfilled. I'll have to get a little tube and suck out some of that. pulling down a vacuum. I guess I wasn't really sure what would happen. I thought something more would happen. But it's going. Sucking down a vacuum. I like it. Pump down there. Pumping. Good job, pump. Alright, we got some evidence of outgassing here. I closed the main stopcock. So we got the pressure is rising, but if I open the main stopcock, it's going back down. So the system will take a while to outgas with all the residual gases in there, but all right, well, this is pretty exciting. I'm excited to make my first tube, process a tube. That will be, I guess, the next video. Seeing if we can get all this that we got set up together, the bench with the bombarder and the vacuum equipment all finally assembled together and working in the same place in tandem. So we'll have to see what we can do in regards to tube making. So, well, thank you for joining me on this journey. I hope you enjoyed. I did. It was a lot of fun putting all this together. So, hit subscribe for more neon related videos, and we'll see you next time. Okay, so I was peeling off all the silicone from this old metal manifold, and check this out. This is a Swagelok Ultra Torque connector. Thought that looked kind of strange, huh? I got the O-ring and the sleeve in backwards. It's supposed to be like this. That O-ring in the middle. They have it right on that very edge. It's supposed to fit in that groove. No wonder it leaked. Probably dropped a couple grand on this brand new Daco manifold because the O-ring and the sleeve were in backwards.